Today's lesson is on common angles in the unit circle for part of our trig. We do not allow the use of the unit circle, which you see here. Miss Kerzeder probably gave you a copy. What we are requiring you to do is learn the hand trick, the left hand answer trick that I will show you tomorrow in class. So you can reference back to this all you want, but when you get to an exam, you're not going to be allowed to use this. And when we say we want exact answers, we don't want decimals. So there's parts of the quiz and the exam where it says give exact solutions. The answers must be in these forms where you see the square root of 3 over 2 or 1/2, things like that. So just be aware of that you're not going to be able to use a calculator for those because decimal equivalents are not good enough. So anyway, we're going to be talking about the unit circle. And remember, a unit circle has a center at 0, 0, and a radius of 1. So this is a unit circle. Okay, that's a unit circle diagram. It has an equation. The equation for the unit circle is that equation. Anytime you see x squared plus y squared equals, and that last one is going to be the radius squared. That's going to be the equation for a circle. Now, your calculator can't graph a circle unless you turn off the function and so on. So it's something that you have to deal with if you're trying to look at a circle on a graphing calculator. But beyond that, that's what it is. Going on, angle measurement. Two things that have to come up. Positive direction is counterclockwise. Negative direction is clockwise. Okay? And we've already talked about this. We talked about reference angles, coterminal angles before, whereas an angle that's 210 degrees is the same as negative 150. Those are the same thing. So 210 degrees is the same as negative 150 degrees. They get to the same spot. Now, your next question is, well, what is this 30 degrees then? So these are coterminal. Coterminal. The next question is, what is that 30? That 30 is not coterminal. That 30 is what we call a reference angle. A reference angle, it's referring to, or its relationship to the x-axis. How far is it from the x-axis? Okay. How far is it from the x-axis? And that is what a reference angle is. An angle between 0 and 90. It's always between 0 and 90 degrees. That will represent the given angle relationship to the x-axis. So how far is a 40-degree angle from the x-axis? 40 degrees. How far is a 160-degree angle from the x-axis? Well, 160 degrees is over here. This measurement is 20 degrees. It has a 20-degree reference angle. That's what reference angles are. How far are they from the x-axis? The next one, 300 degrees is over here. How far is that from there? 60 degrees. So it has a 60-degree reference angle. Pi over 6. Now, you could go through all the work of rewriting it into degrees, then calculate it, and so on. But if it starts in degrees, it should end in degrees. If it starts in radians, my answer should be in radians. How far is pi over 6 from the x-axis? Well, it's pi over 6, 30 degrees. 5 pi over 3. Well, 5 pi over 3 is going to be somewhere over here. So a full circle, or not quite a full circle. 6 pi over 3, remember, is 2 pi. So 2 pi, in other words, 6 pi over 3 is not quite. So how far is that? It is pi over 3 from the x-axis. That's its reference angle. Negative 12 pi over 10. Negative 12 pi over 10. Let's reduce that first. Negative 12 pi over 10 is negative 6 pi over 5. So we go this way. It's going to be somewhere up here. How far is that from the x-axis? Well, this is negative 10 pi over 10. So, in other words, Let's subtract 5 pi over 5, 1 pi, because that's a half a circle. So this is just pi over 5. It's not positive or negative. We don't worry about its absolute value. How far is it from the x-axis? In this case, pi over 5. Reference angles. Going on, definition of sine and cosine. On the unit circle, we know that A is our run. Remember we talked about rise over run and slope and all that stuff. This is the x movement. This is the y movement. So if I have an ordered pair x, y, but as you know, if it's over 1, if this is theta, and I have the side opposite over hypotenuse, y over, or in this case, b over 1, that is the opposite over hypotenuse. Opposite over hypotenuse is simply b, so that is the y value. The y value is always the sine value on the unit circle. And if I take cosine, that's going to be a over 1. Cosine is adjacent over the hypotenuse. That's just a. So every ordered pair on the unit circle actually represents the sine and cosine. And if we want to in turn take that a step further, we can take sine over cosine to get tangent. So that's another relationship that we have here as well. Sine over cosine is tangent. Summary, this is the important piece right here. Okay, sine is the y coordinate on the unit circle, sine of theta, whatever theta is, and cosine of theta is the x coordinate. Okay, so what does that mean? What that means is on a unit circle, when I have a unit circle, and I have a 50-degree angle here, it is y units up, x units over. If I have an angle over here that's also 50 degrees, or another 130 degrees, it's 50 degrees up. This angle is 50 degrees. It has a reference angle of 50 degrees. It's going to have the same y value, but instead it's going to have a negative x value because it's going the other direction. But it's still above. Okay, so every 50-degree angle, every angle that has a 50-degree reference angle has the same y and either the opposite x values or sometimes opposite y values if it's below. If it has a 50-degree reference angle or a 60-degree reference angle, every angle that has that same reference angle will have that same ratio of sine or cosine, but it might be positive or negative depending on the quadrant it lands in. And that's the key part, is remembering what those are. And there's an easy way to do that, which we'll talk about at some point. Let's see if you can figure it out in your assignment tomorrow. But that's why we need to know reference angles, because we relate the reference angles to how far it is from the x-axis, and that can tell us the relationship between the sine of 50 degrees and the sine of 130 degrees, or the cosine of 50 degrees and the cosine of 130 degrees, or the cosine of 330 degrees. Sorry, 310 degrees, because they all have a 50-degree reference angle. So that's the importance of reference angles. Continuing. Definition of tangent. Right? That relationship we've already pointed out. One other thing you might also want to realize is it's rise over run. We know rise over run is slope. Rise over run. Well, if you take rise over run, isn't the rise the sine and the run the cosine? So isn't slope of this line that's being represented here, the slope of this line, isn't that just sine over cosine? And that's what we're saying is true, so therefore the slope of a line is the same as tangent of theta. The slope of a line in reference to, or with its relationship to the x-axis, is simply always going to be the tangent of theta. All right, continuing. All right, we got a couple examples here. Use a unit circle to diagram to find the values for cosine negative 270. Well, remember, negative 270, that's the same as cosine of 90. and the cosine of 90. Now I'm going to refer back to the diagram, but remember, we're not going to have the diagram on everything. Cosine of 90, so remember it's cosine sine, negative 270, cosine of negative 270 or positive 90 is 0, just by looking at the diagram. So that is equal to 0. How about the sine of negative 270? The sine of negative 270 or sine of positive 90 is 1. And we'll talk about the hand trick in a minute, in our lesson tomorrow. All right, use a unit circle diagram to find the exact values of the sine of 4, or sine, cosine, and tangent for when the angle is 4 pi over 3. 4 pi over 3. How many degrees is that? Okay, well, 3 pi over 3 is 1 pi, so that's 180 degrees. And plus pi over 3 is another 60 degrees, so that's 240 degrees. Now, this is just one way of doing it. You could still go back to the same other way. 4 pi over 3 times 180 over pi, and you're going to get the same answer. Right. So if I do that, 240 degrees or 4 pi over 3, I need the sine, cosine, tangent of 240 degrees. Here's 240 degrees. So the sine is negative square root of 3 over 2. Cosine is negative 1/2. Sine of 4 pi over 3, negative square root of 3 over 2. Cosine of 4 pi over 3 is negative 1/2. And the tangent of 4 pi over 3 is the fraction of those two, sine over cosine. So negative square root of 3 over 2 over negative 1/2. The negatives will cancel out. And then I'm going to multiply the top and bottom by this reciprocal, because I don't like a fraction within a fraction. The negatives cancel out. So that's going to leave me the square root of 3. So the tangent is the square root of 3. All right, so then use a unit circle diagram to find all angles from 0 to 2 pi with a cosine of 1/2. Cosine of 1/2, we just found that cosine of 240 degrees is negative 1/2. We want positive 1/2. So if that's a 60-degree reference angle, is 240 degrees. So 60 degrees would have a cosine of 1/2, but now we want our answer in radians because it's asking for it in radians. It would say 0 to 360 if it wanted it in degrees. So this is pi over 3. Where else is cosine positive 1/2? Well, it's the distance this direction that's positive, so it would have to be down here. What would be a 60-degree reference angle? Well, that would be 300 degrees. But 300 degrees written in radian form would be 5 pi over 3. Okay, so those are our two answers there. And that is all.